All right, well, we'll go ahead and get started. Is everyone here to learn about text analytics today? Otherwise, you might want to get up and leave, but that's what we're going to talk about today. So I'm Jason Toyne. I'm the Chief Technology Officer at Kingland, and I am a self-proclaimed data nerd. I'm going to be co-presenting this today with my colleague Jesse Sommerfeld, who is the head of data science at Kingland. He is also a data nerd. We do have some t-shirts that kind of celebrate the data nerd in Iowa. And we have a couple different colors. One is Iowa State, and the other is University of Iowa color. So thank you for coming today. All right. So I'm going to give a little bit of quick facts about Kingland, who we are. This is not going to be a sales pitch on Kingland today. We're going to dive into text analytics and talk about that in a more abstract and general way. Kingland was founded in 1982. We've been in business for over 25 years writing software. That's what we do. We write software solutions for really 4 different industries, which we'll get into here in a little bit. We have 250 employees that are located worldwide. We have 2 office locations in Iowa. Our headquarters is in Clear Lake, Iowa. And we have a development lab in Ames, Iowa. That's right in Campus Town. You may have seen us right there on Lincoln Way and Welch. We bought a block there and put up a 3-story building and have been there in that area for about 17 years. We are privately owned, and again, we write software that is very much focused on data and data management. So the software that we write is we write it for really 4 different industry areas: banking and capital markets, public accounting, retail, and insurance. A number of years ago, we realized that the software that we write is very custom and very solution specific for our customers, who are all, I think they are all Fortune 500 companies. So very large companies that have very specific software solution needs. So we would write custom software solutions for each and every one of those. What we realized is that a lot of the stuff that we were writing was the same. So a number of years ago, we started what we call our Kingland platform. It represents the foundational set of capabilities that we use to build the custom solutions. And our goal with that platform is to really be able to drive about 80% of the technology need with the platform, so that we only have to build 20% on top of that that's custom. We have an area of our platform called text analytics, which is what we're going to talk about today. And by the way, I think I said this, but we're going to leave some time for questions at the end, and if you ask a question, you'll get a shirt. I should have made that clear. And yeah, we have like 10 of them, so 10 questions. All right, so what is text analytics? Is everyone familiar with what text analytics is? There's a lot of buzzword bingo around, in recent years especially, around kind of this field, this area of computer science. And so it sometimes is unclear. So I'm going to just talk a little bit about what it is. I'm going to kind of set up the business case for text analytics. I'm going to try to take 10 minutes to do that. I'm going to try to take 10 minutes to talk about an architecture that you can use to implement your own text analytics solution with whatever business you're in. And then Jesse is going to spend about 10 minutes and actually walk through the creation of a custom NLP, natural language processing model for text analytics. And he's also going to show some software that we've built at Kingland, which is our text analytics platform. So the buzzword bingo that you'll see a lot of is, as it relates to text analytics, is you'll hear cognitive. IBM kind of started coining that term 10 years ago or so. Then, in more recent years, we've heard about artificial intelligence, which is a very, very broad area of computer science. Then we started hearing about machine learning in support of these 2 things, which is another broad area of computer science. And when we get into text analytics, we use a little bit of techniques in all these areas. Natural language processing, which you'll see some of it here in a bit, is just one of those. But in order to provide our text analytics platform, we use NLP, natural language processing. We also use things like convolutional neural networks to find tables with it, like an image of a table within a PDF document, as an example. So there's all kinds of techniques that you have to use in order to really extract the content. And the goal of text analytics is to take an unstructured document, and this is specific to, there may be other use cases, but this is very specific to what we do. Taking documents that represent unstructured content and pulling the structure out of it for whatever purpose. We'll get into that here in a bit. It's super important though, because 80 to 90% of data in businesses and organizations is unstructured. And unstructured content, if it's not clear what that is, it's a written contract that was typed out by someone 30 years ago, 50 years ago, whatever, and was later like scanned in and is now stored electronically. It is, it's a PDF document that represents a mutual fund prospectus, which is very free-form and very marketing-like, but represents important terms and conditions. These are examples of unstructured documents. And then finally, because of this, less than 1% of the world's data is ever analyzed. So there is gold in them, their data hills, as I like to say it. So we care about data. Our customers care about the data. And as we look at text analytics, we have documents that have data in them, and we need to be able to extract the data from those so that we can make decisions. Okay? So we've invested heavily in text analytics. It's been actually about 10 years ago. I would say we were one of the early adopters, bleeding edge, around text analytics as a company. IBM even 10 years ago gave us the CTO Innovation Award for our text analytics work at the time. So we're very much ahead of the game, 10 years ahead. But what's interesting is if you look at Gartner, they would still say text analytics is at the peak of inflated expectations, which means caution. If you're a CIO in the room, caution. Don't invest a lot in text analytics right now because it's scary. But we've already had 10 years of experience in this. So there's two ways to look at that. One is to get cocky and to say, we already know everything there is to know about text analytics. I mean, Justin does, but the other way to look at that is to say, what more can we learn? How would people use this technology? How can we learn from how people want to use this technology and make it even better? And that's what we did this year. So this year in May through June, we did a roadshow, is what we called it. We talked to 25 different companies that were represented across these 4 major industries that we work with. And we showed technology, we showed software, we did prototypes and proof of concepts with them, and we talked to executives, technical leaders, and practitioners of data or database tools. And the types of questions that we asked are, what are your primary use cases for where you have unstructured content that it would be really, really valuable to be able to pull some structure from that and use that. For that, what are the sources of that data? Where is that data stored? Where could it be retrieved? And then, if you had the interesting facts that were in that data, how would you use it within your company? How would you integrate and use that data? And the results are interesting, and I think the last bullet is probably the most interesting that thing that we found out of this. So what we definitely found is that everyone is very, very interested, and we're seeing budgets increase around spending on text analytics. I think people are starting to realize that it is very much a viable technology. One of the reasons for that in recent years is, I had mentioned 10 years ago we were already doing this work, but we had clusters of Linux servers running in-house in our own data centers trying to process the load that we needed to process, and we couldn't keep up. With cloud and the capabilities there, we have compute instances everywhere that can be very specific for a purpose for what we need to process. So if you want to just have Intel-based processors over here, you can do that. You can process with as much horsepower as you want for certain types of cognitive load or AI and text analytics load. Over here, you could have GPUs running, it's very powerful, and when you don't need them, you just shut them off. But the last bullet is really interesting because while there were all kinds of documents and data that people care about, what we found is there's really about 2 or 3 categories of really common use cases. So What type of data did the group of 25 that we worked with care about? Consistently, we found that they cared about these 4 areas of data. They care about organizations. So when we say organization, think about that as it's companies. So Microsoft would be a company, Kingland would be a company. It's the information about those companies. And they care about that because those companies might be their customers. They may be counterparties. They may be competitors. They may be vendors to them. But they care about that data, and that data is represented in all kinds of unstructured content. They care about people, because obviously people are going to be the customers. But they also care about other types of people, like directors and officers. This becomes really important when you start to look at risk around data. You want to know who people are that work for companies. And they care about those employees and as well as their own employees. They care about product data that's represented in unstructured form. So on the banking and capital market side, those products might be equities, fixed income, and securities products. But we do a lot of work with grocery as well. And on that side, they care about groceries. You know, Dannon yogurt is interesting to know about. The other thing they care about is critical data. So think about this. This is just kind of everything else. But critical data is all these important terms and conditions that are represented in unstructured content. So imagine that there's a contract. The contract, like I mentioned, was typed out by hand 30 years ago. It was scanned into some digitization device 10 years ago. It's on file somewhere. Wouldn't it be great if you knew the customers that you had contracts with and what the terms and conditions were, and you could extract that? That's hugely valuable. So what were the sources? A lot of our customers in the banking and capital markets and the audit and accounting space were very interested in the news. And we're going to show some examples of that here later, what the crazy stuff you can just pull out of the news every day. The other is regulatory filings. So think about like the Securities Exchange Commission. Every single mutual fund prospectus, we all probably have mutual funds. We probably are invested in them in some way or shape. You've received a prospectus, right? And you know what that looks like. It's like a marketing document that's usually like in PDF form. Those are all, every mutual fund that's issued in the US has to have their prospectus document filed with the SEC Edgar. For example, we do a lot of work with Depository Trust Clearing Corporation, who settles all trade activity in the US each day for $2 quadrillion a year. They have the settlement data, which they're actually settling trades against those mutual funds. They hired us because they wanted to know that in these prospectuses, the 300 terms and conditions that are in those prospectuses, how do they match the settlement information that they're using to actually trade? Can you imagine if you're a customer and you thought there was an important term in that mutual fund that actually isn't actually what's used to settle trades against that each day? That is a huge problem. And we find issues with those every single day for them through text analytics. So those are the types of sources. And this will be important throughout the rest of the presentation. What are the interactions? So we found that there's really 3 styles of interaction that these prospects that we talked with and our current customers we talked with care about when it comes to the data that we're extracting through text analytics. They care about exploration. So think about this in its simplest form. What if you could pull all the content in unstructured form, but actually index it? So now you can read that, you can search that content, you can explore through that content, and you can quickly identify the types of information, the customer information, the people information, the information that you're looking for in that documentation. That's Explorer. So just get it in there and put powerful search mechanisms on top of it and let people search. The left-hand side is Alert. So what if you cared about IBM as a company? Maybe they're a vendor of yours or they're a customer of yours, and every time they pop in the news for a certain type of news, like maybe a merger or an acquisition or something like that, you want to know about it. That would be an alert. So you're going to very specifically say what you care about, and then you're going to get alerted whenever we find something in unstructured content that has occurred related to what you care about. And then extract is just what it is. You're pulling those important terms and conditions or pieces of those attributes out of the content. And here's an example where, I don't know what this is. This is it's some sort of a regulatory filing.
SEC 8K.
SECAK, thank you, Jesse. So this is filed with SEC Edgar. It's a public website you can go to. You can harvest this content. You can see it right here. We harvested this. We can see that First Community Bank Shares Incorporated entered into an agreement with a plan to merge with Highlands Bank Shares Incorporated. Right there, that's really interesting because there's two ways I could explore, and if I'm just doing a search, let's say that you're in another bank. Let's say you work for a bank, and a representative from Highland Bank Shares comes into your office and says, hey, I want to take a loan with you. Wouldn't it be great if you could just go to a tool and quickly search and say, what's happened with these guys recently? You know, Google doesn't index this. So wouldn't it be great to know that they just agreed to merge with someone else at risk alert, you know, maybe don't lend to them. And so this is why this starts to get interesting. The other side of this is alert. What if they're already a customer of yours? What if you have money with them? What if somehow they're exposed to you, and now the fact that they're merging with a different bank, you could set an alert for whenever they're in the news, and now you start to get informed of that because all of a sudden maybe there's a risk to your business. So there were quite a number of use cases that we came up around these different interaction styles. Risk monitoring were a couple that I just gave out. Client relationship management is another one that may resonate with you. You know, for example, if you have customers and you have customers of any volume size, one of the ways that they're going to interact with you is to send you emails. And wouldn't it be great if you could pull, those emails are unstructured obviously, what if you could pull that unstructured content in and do things like sentiment analysis against it? What if you could know if they're happy, if the majority of your customers are upset? If you start to see that specific products are mentioned in those emails, you could quickly start to triangulate where you might have issues in your business, as an example. That would be client relationship management. And operational efficiency, a great example. My son did an internship at a manufacturing company this summer. And every day at the end of the line change, he's an engineering student, and they were working the lines. And every line change, they would, on a whiteboard, draw up like the problems they had, you know, write them down. They'd write them on a piece of paper or whatever, but then take a picture maybe. What do you do with that? 1 year, 2 years, 3 years go by. How do you actually take that content and make it useful if that's not in structured form? So this is where text analytics can come in very handy. So I'm going to skip that slide. All right, so how are we doing on time? All right, I'm going to get through this a little quicker because I want to leave some time for Jesse, obviously. So this is a logical architecture. We're going to talk architecture here for a little bit. Now this isn't how you should do text analytics. It's how we did it. And hopefully it kind of gets your creative juices flowing and gives you some ideas for how you could work with this. So I'm going to go look at this high-level logical. I'm going to go in a little bit more detail after this. So the gist of text analytics is, of course, we start with documents. So we have sources that have documents. We have to have a way to bring those into a system and land them somewhere where we can do further processing. We do that by landing them into a data lake. We've partnered with AWS. We work with them a lot on a number of different projects. Pretty much, well, all of our, we used to have our own data centers and such. Now everything is in AWS. This is a completely cloud-native architecture working with AWS. So we landed in AWS. We store all the documents in the data lake. We run processing logic on top of those documents to extract the content that we care about. We use all kinds of techniques for that. That can be things like OCR, convolutional neural networks for table data extraction, document classification, sentiment analysis, NLP, natural language processing, NER, named entity recognition. We run all these techniques to get the data out. And that's represented here. We put UIs on top of this so that we understand how the data is processing, but also so that we can do the exploration we talked about before. And then finally, we talked about how we do extraction and we do alerts. We provide a lot of different mechanisms for how you want to be alerted. So you might want to be alerted by subscribing to a queue. And whenever a certain type of message drops in that queue, you care about it, you pick it up. You may want to get emails to get alerted. There's lots of different ways. You may want to get alerted through an API call. So that's the right side there. So now I'm going to dive into this a little deeper. So this is more of a deeper dive architecture. There's a lot of text here and eye candy. I'm going to kind of zoom around and walk you through this. And I'll get into some of the specific technologies and how we actually make this scale. I mean, this has to be petabyte scale. There is a ton of data, as you can imagine, that we're harvesting and pulling and need to process against. So, of course, data comes in as inputs. We land it in a lake. We're going to talk about a dispatcher that we use, which allows for, if you think about what the dispatcher does, it basically just wires together all the logic steps that have to happen to extract the content that we care about. So again, I talked about a convolutional neural network. So let me explain a little bit about what that is. So something as crazy and seemingly as easy as identifying where a table is within a PDF document is extremely hard. Some tables have lines around them, some don't. Some of the columns have lines that separate them, some just use space. Some rows have lines, some use space. There's a mix and match of all those different things. A PDF document doesn't tell you where the table starts and where the table ends. There's nothing in the markup that tells you that. So how do humans find that? You see it. You visualize that. And so convolutional neural networks are used when you look at like on Facebook and it knows that it's your face or your wife's face or whatever. That's convolutional neural networks they're using to do that. Well, we actually found that that technique helped us actually identify where the table is, because a human sees a table as a picture, as an image, as like as a shape. So one of the first steps that we have to do when we do document processing, if we're trying to get the contents of a table, is we have to find where the table is. So we have to run this type of approach first, and then once we find where the table is, then we can apply the next steps of like NLP or NER to that. So these steps are all orchestrated by the dispatcher. And the steps themselves are what we call these DACs, data lake aware components, okay? So again, eye candy and the screen's not real big, but I'll try to walk through this. So the data lake service, we're pumping a ton of data, all these documents into this data lake, and so this thing needs to scale. The way that we make that scale is we run these as, everything's Dockerized, and so containerized. We run an Elastic Container Service, a number of hosts, EC2 instance hosts. These Docker containers sit on those hosts, and we can scale in and out as the volume of the data that we're processing or trying to load into the lake changes. So that's this, okay? Everyone familiar with AWS terms? And all right, we can talk about it later if you have questions. So then the data lake itself is documents are super, super good stored as objects. So S3 in AWS is a perfect storage mechanism. Now you can store them on magnetic storage, on EBS, block-based storage. You can store them a lot of different ways. It's just super cheap to do it in S3. So we use S3 for that. All the metadata and stuff that we collect about the data, we store in a Elasticsearch index. And then we back that Elasticsearch index with DynamoDB, which is a NoSQL-based database. Okay, so document comes in, we have to process it. The first thing that happens is the message goes into a queue and says, document landed in the lake. The dispatcher says, okay, what kind of document is it? And what steps should I run next? The dispatcher puts that message in a queue. The DAC side of the house starts to run. A DAC is, again, it's a discrete piece of logic that has to run on the document. There could be hundreds or thousands that run in a document by the time it's done processing. Each one of those runs in its own Elastic Container Service and has the ability to scale infinitely, horizontally. We can also scale those up as we need to, but this is where if GPU is the right kind of compute, we use that. If EC2, T2 is the right size, we use that. If M4 2 extra large is right for that kind of process, we use that. Each one of those steps has its own ECS and its own ability to scale up and down independently. Okay? So, I think we're doing good here on time. So, what we're going to do now is, and we can come back to this with questions later, We're going to have Jesse spend about 10 minutes, and then hopefully we have about 10 minutes left for questions or discussion. Jesse is going to show how we create a custom model, why we would create a custom model for NLP, natural language processing, and then show one of those created. And then he'll show some of our software in the Explorer mode that we talked about.
Okay, so before I get started, I'm going to go ahead and in the background, I'm going to kick off actually the process of training a new model so everyone can just watch it happen, I guess. So it's not, and it's kind of blurry, but so at Kingland, we don't really prescribe to the concept of having kind of one single language model to be able to handle all of your natural language processing needs. Now, there's been advancements in the NLP industry, but that's our stance is really to sort of customize towards the content that you're actually trying to process. So I'll use a hypothetical real-ish world situation to kind of demonstrate this. So let's say you have 3 people that you can choose from to read any given document. Okay, you've got like a news anchor, you have a medical doctor, and you have an attorney. Okay, and the first set of documents you want to have read are your medical records. Okay, so outside of the antagonists in the room, which of those 3 people are you going to choose to read those documents and consistently be able to interpret them for you? Your doctor, thank you. And then that's great. So let's say that the next set of documents is maybe some sort of agreement that you have with another company or an organization. It's some sort of contract. Same 3 people are available, that news anchor, medical doctor, an attorney. Which one are you going to choose? An attorney, yes. You're probably going to have general counsel if you're a large enough organization, or you're going to have attorney services available for some sort of review and red line and all that. And so why do we do that? If anyone wants to respond.
Because they're experts.
Exactly. It's called expertise. And so how do you gain expertise? Yes. There's certain terms in language and the way, and linguistically, each document can be so much different. So generally, as humans, we can context switch, but I wouldn't really want certain people maybe pick a name out of a hat at the organization and say, hey, you're going to read any sort of contract that I have. And so we take and do something. I'm not saying that you can't do it, it's just that I might take the opinion of someone else a little bit differently. So we take the same stance. That way, based off of the input content that we're dealing with, we will train around that content in order to better consume, process, and make sense of the actual text. So I'm going to go ahead and switch around. So the first, and I just had that running, I'll come back to this. So the first step that we actually go through when we're going to maybe consume a new source of content, right? So it could be, hey, I've got these batch of documents and I want to process them. So first you need to obviously collect them. There's sort of an exploratory phase that you need to go through. You need to kind of produce a corpus of those documents, and you'll want to carve off. We split it into 3 sets. We use an evaluation set, and then we leave the remainder for maybe training and test sets. So the key there is that by producing an evaluation set that we feel best represents the corpus, we can annotate that evaluation set, come up with the gold standard answers that an SME would produce. So this is where humans actually do get involved. This isn't black magic. It's not. It's just.
I haven't become self-aware yet, which is probably good.
Yeah.
I mean.
Yeah, the data collection, annotation, cleansing is still 80% of the problem usually, and so it's very key to be aware of that. And I'll jump back to this. But I'll just jump into, if we get that evaluation set, I'll show an example of how you would actually do this manual sort of annotation. We use some tooling to do this. I'm going to launch this. I need to jump over to a web browser. And let's say that I'm an SME. My task here is, man, this is really blurry. Okay, so my task is we want to do some named entity recognition, and we want to just be able to come up with the gold standard answers of, in a perfect world, what would we get for our named entities identified inside of the text. So if we pretend that this is our evaluation set, or really any set, I'm going to go through and I'm going to start highlighting, okay, looks like I see a person here, maybe I see a regulatory term, Securities and Exchange Act.
So this is a manual thing.
Yep,
Right.
absolutely. And
You're
so
just tagging what
I am,
items are.
Yeah,
exactly.
that's right.
So I'm going to go through this, and I can continue to loop through the examples that I have. Once when you have that, though, when you have your first evaluation set, what you can do is you can use any of your language models that you have currently, and you can evaluate how well they're performing against that gold standard. Once you perform that evaluation, you can say, do I need to move the ball forward? Do I need to customize? What do I need to do? Because it might be acceptable to use the current language model that you already have. It might not. It's all depending on your business case and what is an acceptable level of performance that you need. So I'll just jump out of this real quick. And so this output that you saw in the first terminal is really just taking an annotated set of training data. It's looping through. I only did like 5 iterations, and I don't know if you can really tell, but it started at 36%, went to 44, 56, got up to about 75%. We use neural language models. We don't use bidirectional autoencoders or any sort of autoregressive stuff. The models are really large, and we still believe that context is king, and training a specific model or training a model to be able to be tuned towards the contents necessary. So regardless of the fact, neural language models are able to generalize and pick up on that type of thing very quickly. You can use it. You can train them using CPU instead of GPU, so cost efficient for experiments that you're doing locally. And so that's really kind of our approach to it. So next, I'm going to show an example of maybe just a before and after. So we went through the training exercise. We said we went through the evaluation, said we need a new model. We went ahead and trained a new model, and I can show you the performance metrics, but it's really just going to be confusion matrix that you're looking at up here, and you're probably going to look at me and say, I hate you. And so I'm going to go ahead and just load up a before and after view of just one sentence from just new data that's coming in. And on the top, you have an imaginary line. Sorry, I didn't put any HTML in here. In green, you have persons, and in purple, you have organizations. And the top is the generic model. It's the start. Bottom is the trained model. And here we have basically a split of an organization, some company, LP, person. We're erroneously identifying the letters of acceptance, looks like an organization, all that. While you can visually see it's much cleaner on the second set. We've said, we want to know about business terms, regulatory terms, things like that. And so you can see very quickly you can move forward just simply by annotating and retraining. And so I'm going to go ahead and jump into actual software now because we don't have very much time left. So I tried to use the same color, so hopefully this, in that little before and after, so hopefully this works pretty well. So I'm going to go ahead and log into, this is a, it's a demonstration environment of our text analytics platform. It's sitting on top of the data lake, and on the top you have some summary metrics. Over here on the left, you have total amount of documents that are in the lake, the sources that they're coming from, total amount of organizations, people, and events. And that's all driven by sort of what Jason was talking about at the beginning, where people cared about these certain things. So that's really the direction that we went. It's organizations, people, and events of interest. Something is interesting in there for me. And so this is all driven by, first of all, the time frame. So this is just the last 30 days, and it's only configured for 4 sources. So you can see how this can expand pretty quickly. But let's say that I'm a risk individual, and I want to look at the last maybe 6 months. And I'm tasked with reviewing and kind of keeping on top of companies that my organization or other organizations that my organization does business with. Or maybe they're a prospect, whether I'm going to sell to them or I might try and acquire them. It could be quite a few different things. But let's say that, I care about a company called Wedbush Securities. I can simply filter off of my organization's column. I'm down to 2 documents in the last 6 months now that I need to look at, instead of 50,000. Now I only care about maybe some negative stuff, like there's a penalty or fine that exists inside of this document. Uh-oh. Let's take a look. On the right-hand side, we've got the original document that loads up. This is the source content. This is coming from the Securities and Exchange Commission's Enforcement Division. Basically, they're in trouble. That's what it comes down to. On the left-hand side, we have what we call a tag tree. And I'm going to go ahead and minimize so you can see some of this. Okay. So in orange, we have events. In purple, we have organizations. And in green, we have people. And there's actually some other stuff here, and some scaling isn't really working right now, so I apologize. Other interesting information. Now, I do want to qualify. In this environment, we actually use one single model, one single lot model. Like you just talked about how you don't do that, right? We do that on purpose. We want to show people why you can't use that one model. Okay? And so you're going to see some things that aren't necessarily helpful, like paragraph. That is not an organization. Great. All right. But back to the role play, right? So I'm a risk analyst, and I really do care about this fine. What this is going to do is I can interact with this tag tree, and it's just going to jump to the highlighted section of the document that I'm asking for. And so what we see here is that, okay, that's a pretty big fine. And let's say I'm doing business with them. I have some sort of reputational risk exposed here. There's $1.8 million here on the line for them. Or you want to interject? Oh, you're moving.
No, I was just going to say that, you can start to see kind of the value here because these can be hundreds of pages long.
Oh, yeah.
And the large, like institutional banks, banking and capital markets, they pay people. They have armies of people they pay right now to read this stuff.
Yeah,
and just to try to extract, this type of risk information in this example.
Yeah, and we're not under the illusion that really big things aren't talked about in the news. And there's ways for people to get access to that, right? You can set up what used to be Google Alerts or something else like that. The problem is that it doesn't cover everything. It covers big things. And big things in context to someone else. Someone else has decided that it's big for you to read, okay? So anyway, I can show some of these other things, some other named entity types, or money's a named entity type. You can all gain access to this information. So in this view, I'm really just exploring, I'm reading. This application is really just a consumer of the same data that's structured in a way in which it could be provided via an API, a queue, an email, doesn't really matter. It's just consuming that data, and then it's trying to visualize the information. So I'll go ahead and kind of show another example. Who thinks $1.8 million isn't a lot of money? I do. Whatever. Let's see. Let's say that maybe I'm not looking at penalty fines. That's just kind of one example, right? But let's say that I'm just doing business with maybe Dark Star Ventures. Okay. So let's see. A couple days ago. Yeah, that's right. It says 12. Looks like there was a filing here, and I can actually start to expand some of this stuff, and it's hard to read, and I'm sorry, but the first one says mergers and acquisitions. It says name change, director officer change, and spinoff, and then it gives me a count of 3, 2, and 1. So I have some activity going on here with Dark Star Ventures. I'm just going to open one of these documents. This is a Edgar filing. It's a Form 8K. Effectively, any publicly traded company within 4 days is required to file any material event that occurs that's going to affect their business, and that's what this is. So if we go ahead and jump into maybe some of the some of the meat of this, we can start to see it really light up. This is not the same document he had in there. But we have a lot of orange, and let's say I only care about mergers, acquisitions. I can start to just narrow down and only look at that information. Maybe I do care about that director officer change. Sorry. What's going on? Maybe I care about the name change. Where did that go? Previously known as. So as you can see, this can be very helpful when you're just trying to read some content. This is really dense language. Reading this, like there are people that can read it and consume it very quickly, and they're very good at that, and that's great. But it's not that is not a commodity, and that's a human capital has got a capacity.
There's no more questions. Thank you. If you want to come up,